This is the basic proportionality theorem. The statement of this theorem you need to remember, and it goes like this. In a triangle, now this is the triangle ABC, if a line is drawn parallel to one side, so this line DE is drawn parallel to one side, that is BC of the triangle, intersecting other two sides in distinct points. So other two sides means AB and AC. So this line DE is intersecting AB at D and AC at E. So what happens? So this much is given. So let's write this given. There is a triangle ABC in which we have drawn a line DE which is parallel to the side BC. Now what we need to prove? So we need to understand the remaining statement. Now in the remaining statement we have then. So from here to prove starts. It means the line DE divides them means AB and AC in the same ratio. So this DE is dividing AB in two parts and AC also in two parts. So the ratio of the two parts of AB, that is AD and DB, and the ratio of the two parts of AC, that is AE and EC, these two ratios are to be proved equal. So this is the theorem that in a triangle, if it is given that this line DE is parallel to BC and it intersects AB at D and AC at E, then you have to prove that this parallel line divides the other two sides in the same ratio, that is ratio of AD and DB and AE and EC is same. Now all the constructions involve construction, helping lines. So let's draw some helping lines. Construction. Now for construction part, we need to join these two, DC and EB. Just remember that whenever you draw helping lines, those lines have to be dotted so as to make out that these are the construction part. And from E we draw a perpendicular on AB. So this is the perpendicular which is drawn from E on AB, and let's call this as EP. So let's write the construction. Join DC and BE and draw A. Okay, I'll not write AB first. I will write EP. Draw EP perpendicular to AB. Now this is the construction. Now let's see the proof of this theorem. Now for the proof, first of all, we will consider a ratio of areas of two triangles. See, consider the ratio. And which ratio? It is the area of the triangle on the top, that is ADE, and the triangle at the bottom BDE. So ADE and BDE, very easy to remember. DE is the common side. So we have to take two triangles starting from ADE and BDE. So just see what is the ratio of these two areas. We will apply the formula half into base into height. Now for the triangle ADE, this is the perpendicular, so this is the height. And on which side is this height made? This is made on AD. So the formula will be half into base AD into height EP. And if you see the other triangle BDE, this is half into, now here the base was AD, here the base is BD, and the height of the triangle on the top EP is inside the triangle, whereas the height of this triangle BDE is outside the triangle, but the height is same in both the cases. So EP gets cancelled and half also gets cancelled, thereby giving you AD upon BD, which is the first equation which is required in this proof. So you need to remember this first step, that area of triangle ADE and area of triangle BDE should come out to be AD upon BD. Now see, when I consider the ratio starting from ADE and BDE, so both the bases were on this side, then I got the ratio of the two sides which are on the left hand side. Similarly, if I would have taken the triangles from right hand side, that is AED and CED, then I would have got a ratio which is on the right hand side. So I don't need to prove that. I will just write similarly area of triangle AED and area of triangle CED. These two areas are also, the ratio will also be found out like we have found out the ratio in the first step. So that ratio will be AE upon EC. Friends, you don't need to prove it. You can just write it similarly, because if you have to prove it, then you have to draw another perpendicular from D on AC. You can do that, and in some books it is given like that also. But even if you write similarly, then you will not lose any marks in board exams. So let's see the next step. Now, see the part which we have to prove. AD upon DB equal to AE upon EC. This is to be proved. So one part of this, that is left hand side, is here AD upon BD, and the other part AE upon EC, it is on the right hand side of the second equation. So if we have to prove that these two are equal, that is the RHS of these two equations are equal, then first of all we have to equate the left hand sides. So that is a very crucial step now. We have to try and equate the left hand sides of these two equations. How do we equate the left hand sides? Just see the numerators first. In the numerator here, it is area of ADE. So ADE is this triangle. And what about the numerator here? AED. AED is again the same triangle. So the numerators are already equal. What we need to do is to equate the denominators. And for equating the denominators, you need to recapitulate a theorem which you have done in class 9th. That is the chapter on area of parallelograms and triangles. In that chapter, we have done that whenever there are two triangles, I'll shade the triangles for you. BDE, this is one triangle, and CDE, this is the other triangle. Just see that these two triangles are actually drawn on the same base DE. There is a common base. And what about DE and BC? They are parallel. Here we are, it is already given in the question. So these two triangles BDE and CED are actually lying on the same base, and they are drawn between the same parallel lines. So whenever this happens, then the area of the two triangles become equal. So that is what we need to write in the next step. So I'm just writing the denominators, area of BDE. Now area of triangle BDE is equal to area of triangle CED. And what reason will you give? They lie on same base. Which is the base? DE, and between same parallel lines. And which are the parallel lines? DE and BC. So here is the use of the two parallel lines, DE and BC. After this, it is just theory. You have to just write two steps and get to the answer. Now we have proved that the denominator of the first equation and the denominator of the second equation are equal. Here we have proved them, they are equal, and numerator was already equal. So LHS of first equation is equal to LHS of second equation. So we have proved that the two LHS are equal. And why did we do that? Because we wanted to prove that the RHS of the two equations are also equal. So that implies the RHS of first equation will be equal to the RHS of second equation, thereby giving us the desired result, AD upon BD equal to AE upon EC. And this proves our basic proportionality theorem. Students, a very important theorem for board exams, and you just cannot skip this question if you want to succeed in board exams. Take a screenshot of this theorem. This is the exact way of solving this theorem in board exams. Theorem, we all know that Pythagoras theorem is applied on a right angle triangle. Now this ABC is a right angle triangle here, right angle at B. So the statement of the Pythagoras theorem goes like this. In a right angle triangle, the square of hypotenuse, so this is the angle of 90 degree, so the side opposite to this, that is AC, this is the hypotenuse. So the square of hypotenuse is equal to the sum of squares of other two sides. So we are given a triangle ABC in which we have angle B as 90 degree, and we need to prove that the square of hypotenuse, that is AC square, is equal to the sum of squares of other two sides, that is AB square plus BC square. So this is required to be proved. I told you that all the theorems involve a construction. So here also we need to do some construction, a helping line. From B, we will draw a perpendicular on the hypotenuse AC, like this. So this is the perpendicular D. So BD is to be drawn perpendicular to AC. Now this is the construction. Now let us start the proof of this important theorem. Now for proving this theorem, we need to use the concept of similarity. We all know that whenever we have to prove two triangles as similar, then we make use of the AA criteria, that is angle criteria. If the two angles of one triangle are equal to the corresponding two angles of the other triangle, then the two triangles are said to be similar. So I will try and prove triangle ADB, that is the triangle on the left hand side, the small triangle, and the big triangle ABC as similar. So in triangle ADC and triangle ABC. So these are the two triangles I am going to take up. The triangle on the left side with the whole triangle. Now see, angle A is common here. So angle A equal to angle A becomes the common angle in both the triangles. And one of the angles is 90 degree. In this case, smaller triangle, angle ADB is 90 because this is perpendicular. And in the larger triangle, angle ABC is 90. So we need to write the reason, each 90 degree. So now you see, two triangles of the smaller triangle are equal to two angles of the larger triangle. So the triangle ADC becomes similar to triangle ABC by AA criteria. So this is the first step. You need to prove the left side triangle and the big triangle similar like this using the AA criteria. And why do we use similarity? Because we want to equate the ratios of the corresponding sides. Now I will write the ratios of the corresponding sides. If you see the smaller triangle, the hypotenuse of the smaller triangle is AB. So I am taking AB. And what about the hypotenuse of the larger triangle? It is AC. So AB upon AC, that is the ratio of the two hypotenuse, becomes equal to ratio of the bases. See, the smaller triangle, the base is this because we have taken these two angles. So the base is AD. So I am writing AD in the smaller triangle. And what about the larger triangle? I have taken this angle and this angle. So base is AB. So you need to give the reason again. Corresponding sides are proportional, or you can write ratio of corresponding sides are equal. So are proportional. Now once we get to this step, the next step is to cross multiply this. So we will get AB square equal to AC into AD. Now this is the equation number 1 which we required. Now if we would have taken the triangle on the right hand side, then we would have got another result. I will write that result as similarly. Now see, when I took the triangle on the left hand side, everything is starting with A, that is AB square equal to AC into AD. So when I would have taken the triangle on the right hand side, everything would have started from C. So similarly, CB square, that is BC square, will be equal to CA, that is AC, into CD. Now this is equation number 2. You don't need to prove it, just write it similarly. And now add the two equations, you will get the desired result. Adding, we get AB square plus BC square, which is the left hand side, and on the right hand side AC into AD plus AC into CD. So I have added the left hand sides and the right hand sides. And on the right hand side I have AC as a common side. So AD plus CD will be left in the bracket. And if you see in the figure, AD plus CD is actually AC. So this gives AC into AC equal to AC square, which proves the Pythagoras theorem that AB square plus BC square is always equal to AC square. Now this is the proof of the important Pythagoras theorem. Students, you can take a screenshot of this. This is the exact method of solving this important theorem. Now let's see the next theorem, that is the converse of the Pythagoras theorem. The statement of this theorem goes like this. If in a triangle, mind you, we are drawing a right angle triangle, but we are not marking this as 90 degree, because if this is 90 degree, then this becomes Pythagoras theorem. Now we need to prove the converse. So we need to prove that this angle is 90 degree. So if in a triangle, any triangle, the square of one side is equal to the sum of squares of other two sides. See, square of one side, I am not calling this side as hypotenuse because I have not yet proved that it is 90 degree. So what happens when the square of one side becomes equal to the sum of squares of other two sides? Then the angle opposite to the first side is 90 degree. You will understand this in a better manner once I write the given part. Now, in given part, we have a triangle ABC in which it is given that the square of one side, that is AC square, is equal to AB square plus BC square. So this is already given. So what was to be proved in the previous theorem, that is Pythagoras theorem, now it has become given. And now in the second part, that is to prove. So we will write the to prove here. We have to prove that angle opposite to the first side taken here is AC. So angle opposite to AC is 90 degrees. So we have to prove that this angle D is actually 90. So as in the case of all theorems, we have to do some construction in this theorem also. So let's see the construction part. Now for the construction part, I will draw exactly its same triangle. This triangle will be dotted because all constructions are done in a dotted line. I'll call this triangle as PQR. And how I have drawn this triangle? I have drawn this triangle with angle Q as 90 degree, PQ as equal to AB, and QR as equal to BC. So I'll write this here. Draw triangle PQR in which angle Q is 90 degree, PQ is drawn equal to AB, and QR is drawn equal to BC. So this is the construction. Now let's see the proof of this theorem. We need to prove that this angle B is 90 degree. Now for proving this, first I'll make use of the Pythagoras theorem in the triangle PQR. Since it is a right angle triangle, I can use the Pythagoras theorem. So in triangle PQR, PR square will be equal to PQ square plus QR square. This is the Pythagoras theorem. But I have taken PQ equal to AB and QR equal to BC as construction. So PR square becomes equal to, in place of PQ, I will put AB. So AB square. And in place of QR, I will put BC. So BC square. So this is the first equation which is required. Also, I have something given also. See, AC square is actually equal to AB square plus BC square. Now this is given and this becomes the second equation. Now once I get to these two equations, rest of the process is very easy. How? See the RHS of these two equations, AB square plus BC square, and here we have AB square plus BC square. So from 1 and 2, since the RHS of these two equations are equal, I can equate the left hand sides also. So from 1 and 2, PR square becomes equal to AC square. So that gives PR equal to AC. So I have proved that this side PR is equal to this side AC. And now if you see the two triangles ABC and PQR, already two sides were taken equal, PQ and AB were equal, QR and BC were equal, and now I have proved that the third side PR and AC, these two are also equal. So that gives me an important result that the triangle ABC is congruent to triangle PQR. Mind you, it is congruent, not similar. Why? Because all the three sides, corresponding sides are equal. So the two triangles become congruent by SSS rule. And what happens when two triangles are congruent? We can apply CPCT, that is corresponding parts of congruent triangles. That implies angle B becomes equal to angle Q by CPCT. But what is angle Q? We have drawn this angle Q in construction as 90 degree. But angle Q is equal to 90 degree. We have done the construction. This is the reason for that. Therefore, angle B becomes equal to 90 degree. Now, this is the result we were required to prove in the converse of this important converse of Pythagoras theorem. So, hello dear students. Third video in the series of videos on triangles. Very important for class 10th. And this video will contain the fourth theorem and its proof along with some questions based on this theorem. So this is going to be a long session, and all the students, you need to see the entire video in order to see what questions have come in board exams, previous year board exam which have been conducted previously, and that will give you a glimpse on what questions you have to focus on. So let's see the theorem first. The statement of the fourth theorem goes like this. The ratio of areas of two similar triangles, very important, two similar triangles. So these two triangles, triangle ABC and triangle PQR, they are given as similar. So let's write what is given in the theorem. It is already given that triangle ABC is similar to triangle PQR. So what do we need to prove in this? The theorem starts with that only, the ratio of areas. So area of triangle ABC upon area of triangle PQR. This is the ratio of the areas of two similar triangles. This is given is equal to the ratio of, so there is some ratio, squares of their corresponding sides. Squares of their corresponding sides. So if we take the side AB in this triangle, the corresponding side in this triangle is PQ. So we have to take the RHS of this to prove as AB square upon PQ square, or if you take BC, then the corresponding side will be QR. So BC square upon QR square, or the third one AC square upon PR square, which becomes obvious now. So this is what is required to be proved in this theorem. Now let's write the construction. What are the helping lines we need to draw for proving? From A, we need to draw a perpendicular on BC like this, and let's call this point as M. And similarly from P, we need to draw a perpendicular like this on QR, and let's call this N. So I'll write it here. Draw AM perpendicular to BC and PN perpendicular to QR. Now let's start the proof of this important theorem. Now first of all, I will take up this LHS of what is to be proved. Now consider the ratio area of ABC, that is the triangle on the left, upon area of PQR, the triangle on the right hand side. So what is the formula for finding the area? It is half into base into height. So I'll write the formula here, half into base BC into height AM, and in the other triangle half into base QR into height PN. So you can see this is the base, this is the height, and here this is the base and this is the height. So half gets cancelled and I will write it as two terms here, BC upon QR multiplied by AM upon PM. So this is the first equation and I shall use this first equation later on when I proceed with the proof. Now let's see the second part of what is to be written in the proof. This is the first step. For the second step, I shall prove that the triangles on the left hand side, that is this triangle AMB, and the triangle on the left hand side here, that is PNQ. I will try and prove that these two triangles are similar. Let's try and prove that. In triangle AMB and triangle PNQ, can you prove them similar? Yes, we can very easily prove them similar, because for proving triangles similar, we need to just apply AA criteria. So two angles of this triangle should be equal to two angles of this triangle. And which two angles are equal? One of the angles is 90 degree. So that is very easy and obvious. So I'll write that first. Angle AMB is equal to angle PNQ, which is the exactly construction, or you can write each 90 degree. And this angle B is actually equal to angle Q. Can you guess why? They are equal because the larger triangles, that is ABC and PQR, are given as similar. So whenever two triangles are similar, their corresponding angles are equal. So in triangle ABC, if you take angle B, then in triangle PQR, you have to take angle Q. So that is the second thing which is to be written here. Angle B is equal to angle Q, and just write the reason. Since triangle ABC is similar to triangle PQR. Now this is the reason, because these two triangles are similar, their corresponding angles are equal. And now two angles of this triangle and two angles of this triangle are proved equal. So these two triangles are similar. So this is the second step. That implies triangle AMB is now similar to triangle PNQ by AA rule. And why do we prove two triangles as similar? You very well know the reason why we prove similarity, because we want to write the proportionality between the sides. That is, the corresponding sides are proportional. That is, ratio of the corresponding sides is same. So let's write the ratio of the corresponding sides. If you take AB here, you have to take PQ here. So ratio of these two sides, corresponding sides, will be equal to, if you take AM here, you have to take PN here. So see, I have equated the two sides, corresponding sides of the similar triangles which I have just now proved. Now this is the second part. So first part was the area of the triangle, ratio of areas. I got one equation. In the second part, I proved the left hand side triangles as similar, and I got to the ratio of corresponding sides as equal. This is the second part. Now come to the third equation. Also, now see, the larger triangles ABC and PQR, they are already given as similar, and whenever two triangles are given as similar, then their corresponding sides are also proportional. So now I am taking the corresponding sides of ABC and PQR. In triangle ABC, if you take AB, then in triangle PQR you have to take PQ. In triangle ABC, if you take BC, then in triangle PQR you have to take QR. Now you have to give reason for that. Since triangle ABC is similar to triangle PQR, so that is the reason why we have made the ratio of the corresponding sides of the two triangles as equal. Now this is the third equation. Now from 2 and 3, that is the second equation and the third equation, can you find out or derive a result? Just observe the left hand side of these two equations, second and third equation. The left hand side AB upon PQ is same in the two equations. Therefore, the right hand side will also be same. So AM upon PN will be equal to BC upon QR. Now this equation is the fourth equation which is required. And now proof is just one step away. Now write the first equation. From 1, area of triangle ABC upon area of triangle PQR is equal to, just observe here that when we wrote equation number 1, we had area of triangle ABC upon area of triangle PQR as BC upon QR into AM upon PN. So I will write this BC upon QR as it is into this AM upon PN will be replaced by BC upon QR. Why? Because we have proved in equation 4 that AM upon PN is equal to BC upon QR. So I am replacing this AM upon PN by BC upon QR, and you need to write this has been obtained from equation number 4. And as a result, area of ABC upon area of PQR is equal to BC upon QR into BC upon QR, that is BC square upon QR square. So see, in the what we have written in to prove area of triangle ABC and area of triangle PQR, the ratio should be equal to BC square upon QR square. So we have proved one part, and the other two parts you don't need to prove that, just you can write similarly other parts can be proved. Similarly, area of ABC upon area of PQR can be proved equal to AB square upon PQ square or AC square upon PR square. So this proves the theorem, very important theorem for board exams. Students, you can take a screenshot of this exact method through which this theorem is to be proved in the exam, so as not to lose any marks. And if you solve it like this, 4 marks are yours. So friends, after this we have covered now all the 4 theorems. Let's solve some problems based on this theorem now. That is, the ratio of areas of two similar triangles is equal to ratio of squares of their corresponding sides. So here are 2 questions of 1 mark each, which are based on this important theorem. The first question goes like this: if triangle ABC is similar to triangle QRP, very important that you realize that the order is very important in this similarity. And area of the two triangles, the ratio is given as 9/4, and two sides are given AB and BC. You have to find PR. A very easy question. If you have understood the theorem, then this question is going to be a cakewalk for you. So let's see how this is solved. Now see the triangles which are given similar. Whenever two triangles are similar, their ratio of areas is equal to ratio of squares of the corresponding sides. This is what we have proved in the theorem. So since triangle ABC is given similar to triangle QRP, therefore area of ABC upon area of QRP will be equal to ratio of squares of their corresponding sides. Now important thing is which two sides you have to take in order to find the value of PR. Now see one more thing here, AB and BC both are given. You may or may not require both. So even if two things are given, one thing may solve your purpose. So see, BC is the second and third alphabet here, and we need to find PR. PR is the second and third alphabet here. So I will take BC square upon PR square. You have to mention why we have taken this. Since the triangles are similar, ratio of areas is equal to ratio of squares of the corresponding sides. Now this is the reason you have to give why we have written this result. Now see the ratio of areas. It is given as 9 by 4. So I will put here 9 by 4 equal to what is the value of B? BC. BC is 15. So 15 into 15, that is 15 square, and PR square. So we need to find the value of PR. Very easy now. It is an equation in one variable. You can solve and find the value of PR. I will not solve this. I will just take PR square here and take this 9 by 4 as 4 by 9 to the other side. So 15 into 15 into 4 by 9. So PR comes out to be, now this is square, so this is also 15 square, so 15 will come once, and 4 becomes 2, and 9 becomes 3. So 3 cancels out with 15 5 times. So the value of PR comes out to be 10 centimeters. Very easy question. You may get it in 2 marks also. It depends on your luck in the board exam, but normally this is given in 1 mark question. So let's see one more 1 mark question based on this important theorem. Triangle ABC and triangle DEF, they are given similar. Again similarity. The ratio of two sides is given DE and AB. The ratio is 2:3. Area of one of the triangles is given. You have to find the area of other triangle. So it is but obvious from the given data that you have to use the same theorem which we have used here. So again, since triangle ABC is similar to triangle DEF, now see here DE ratio AB is given. So I will take DEF first. Area of DEF upon area of ABC. So I have taken it the other way around so that I can have DE ratio AB, this ratio used here. So if you take DE here, you have to take AB here. So DE square upon AB square. And you need to mention the same result which we have mentioned here. Ratio of areas of two similar triangles is equal to ratio of squares of their corresponding sides. So I have written it in short form here. You have to write the same result which we have written here. Now, the area of triangle DEF, it is given here 44. So this is 44, and area of triangle ABC, this is required to be found out. And what is DE ratio AB? It is 2:3. So DE square upon AB square, it is 2:3 whole square. And now this becomes an equation in one variable. So 44 multiplied by, this is 4 by 9, it will come here 9 by 4, and this area of triangle ABC will move in the numerator to the other side. So 4 cancels 44 11 times. So area of ABC comes out to be 11 into 9, 99 square centimeters. So these are two problems which will make you understand what type of questions may be asked in board exam related to this important theorem. So let's see some more questions based on this theorem. So in this third question now, we are again given that area of triangle ABC is 64 and area of triangle DEF is 121, and both the triangles are similar. So again, very obvious that you have to use the same result. Let us use the same result. Since triangle ABC is similar to triangle DEF, therefore area of ABC upon area of DEF will be equal to, now which two sides are to be equated? We are given EF and we have to find BC. So see, EF is here, BC is here. So we will use BC square upon EF square. So you have to mention that similar statement, ratio of areas of two similar triangles is equal to ratio of squares of their corresponding sides. So same result, that is why I am not writing the entire statement, you can write it. And now just substitute the values. Area of ABC, it is given 64. Area of DEF, it is given 121. BC square we need to find, and EF square is 15.4 square. Now students, after this, a lot of students commit an error of multiplying 15.4 by 15.4, thereby finding the square of this. You don't need to find the square of this because the right hand side is an exact square. So whenever this happens, the calculations become very easy. Let me write one step here. 64 by 121 is actually 8 upon 11 whole square. And on the right hand side you have this BC square. So BC upon 15.4 whole square. So we have all the squares. So squares get cancelled, and now you can cross multiply 11 into BC will be equal to 8 into 15.4. Further, I will not multiply these two also because my calculation will become a little bit complex. But if you bring this 11 here, you can see that 154 is exactly divisible by 11. So you can cancel this 11. 11 ones are 11 and 44, so 1.4, and the multiplication of 8 and 11 1.4 will give you your final answer. So it was a 32, 3, 11. So 11.2 centimeter is the answer which we were looking for. Again a 1 mark question, or if you are lucky you may get it in 2 marks also. So let's see one more 2 mark question. This is obviously a 2 mark question now. And this question is mentioned in I think NCERT also. So you can consult NCERT for this question. The diagonals of a trapezium ABCD in which AB is parallel to DC. So we have a trapezium like this. This is a trapezium. So AB is parallel to DC. So these two are given parallel, and the diagonals intersect at O. So we need to draw the two diagonals like this, and now they are intersecting at O. Now in this we are given that these two are parallel and AB is twice of CD. So AB is double of this CD, and we need to find the ratio of areas of this AOB and COD, these two triangles. So whenever we have to find the ratio of areas of two triangles, so first thing is we have to prove them similar. Only then we can apply the theorem which is written here. So how do we prove them similar? So in triangle AOB and triangle COD, these are the two triangles which are under consideration. Now let's try and prove them similar. This angle, okay, I'll label this angle as 1, and this angle I'll label this as angle 2. So angle 1 and angle 2, they are equal. Why? Because they are alternate interior angles, because the lines are parallel. So they are alternate. I'll write the full form: alternate interior angles. So one angle of this and one angle of this triangle is proved equal. And can you tell me the other pair, which is very obvious now? You can use the alternate angle once more, or you can use the vertically opposite also. So angle COD is equal to angle AOB. It is the vertically opposite angles. So therefore, two angles of this triangle and two angles of this triangles are now equal, thereby proving that triangle AOB is similar to triangle COD by AA criteria. And once you approach similarity, then you can find the ratio of the areas of the two triangles. That implies area of AOB and area of COD, the ratio will be equal to squares of their corresponding sides. And now which sides I will use? I will use the sides which are given here. For triangle AOB, I will use AB because AB is mentioned here. For triangle COD, I will use CD because CD is mentioned here. So here we have AB square upon CD square. Again, you need to mention the same reason: ratio of areas of two similar triangles is equal to ratio of squares of their corresponding sides. And now the answer is not far away. This area of AOB upon area of COD will be equal to, now see what is given. I'll write it here. Since AB is double of CD, that implies AB upon CD. I'll bring this CD this side is 2 by 1. So just put AB upon CD as 2 by 1. You get 2 by 1 whole square. So this is 4 by 1. So your answer is 4 ratio 1. Again, a very important question for board exam, and this question has already come in previous year board exam many times. Let's see the next two questions now. This is question number 5, again a previous year question. Prove that the area of an equilateral triangle described on the side of a right angled isosceles triangle. Now there is a right angled isosceles triangle, so we need to draw that first. So this is the right angled isosceles triangle ABC, in which AB and BC are two equal sides, and we are drawing an equilateral triangle described on the side. So we have to draw an equilateral triangle like this. Now this is an equilateral triangle BCD, and there is another equilateral triangle which is described on its hypotenuse. So hypotenuse is AC. So this is another equilateral triangle. Now let's call this P. Now there are two equilateral triangles here, BCD, which is described on the side, and ACP, which is described on the hypotenuse. So in this question we are given that triangle ABC, in which we have angle B as 90 degree and AB equal to BC. AB and BC are equal. Now these are the two isosceles triangles, triangle BCD and triangle ACP are equilateral. Everything is given in the question, and now what is to be proved? We need to prove that area of this triangle, area of BCD, is half of the area of ACP. Now this is to be proved. Now for this, the proof goes like this. For this isosceles triangle ABC, let us assume that the side AB is x and BC is also x, because it is an isosceles triangle. So the two triangles, the two sides are equal. So AB and BC are equal. So let AB equal to BC equal to x. Now once you know two sides of a right angle triangle, then you can find the third side using the Pythagoras theorem. Very easy. That implies AC square will be equal to x square plus x square. This is Pythagoras theorem. That implies AC square will be equal to 2x square, or AC will be equal to under root 2x square. That gives the value of AC as x into root 2. Now this is the first step. You need to find out the hypotenuse using the two equal sides. And now things will be very easy. Triangle BCD is similar to triangle ACP. Can you tell me why these two triangles are similar? They are similar because they are both equilateral, and in an equilateral triangle all angles are 60 degree each. So 60, 60, 60 and 60, 60, 60 AAA rule, or simply AA rule applies. So both are equilateral. You can just write both triangles are equilateral. That reason is enough. And once you have proved that the two triangles are similar, you can apply the same theorem which we have been applying in this entire video. The areas, so area of BCD and area of ACP, the ratio will be equal to ratio of squares of their corresponding sides. So BC square upon AC square. So what is BC? BC is x, so x square. And what is AC? AC is x root 2, or AC square is 2x square. So you can just put in place of AC square 2x square. So x square gets cancelled, thereby giving you 1 by 2. And if you take this denominator area of ACP to the other side, this becomes half of area of ACP, and this is what was required to be proved. So this is another important question for board exams based on this theorem. Let's see the sixth question. Again an NCERT question. If the areas of two similar triangles are equal, prove that they are congruent. So what is given in this question? Two similar triangles. So triangle ABC is similar to triangle, say you can name anything, PQR. If the areas are equal, so areas are also equal. So area of ABC is equal to area of PQR. The areas are also given equal. And so what do we require to be proved here? Prove that they are congruent. So we need to prove that triangle ABC is congruent to triangle PQR. So let's apply the same theorem again because the two triangles are given similar. Since triangle ABC is similar to triangle PQR, that means area of ABC upon area of PQR will be equal to, I'll write all three results now, AB square upon PQ square. See first two, then second and third BC square upon QR square, then first and third AC square upon PR square. Just mention the same result which we have been mentioning every time, but the areas are equal. But the areas ABC and PQR, the areas are equal. It is given here in the question. So if the areas are equal, then this ratio will get cancelled. That means 1 will be equal to AB square upon PQ square, BC square upon QR square, AC square upon PR square. And now convert this into three parts. 1 equal to AB square upon PQ square, then 1 equal to BC square upon QR square, then 1 equal to AC square upon PR square. So this gives, if you cross multiply, AB square will be equal to PQ square or AB will be equal to PQ. From here, if you cross multiply, BC square will be equal to QR square. That means BC will be equal to QR. And from here, AC square equal to PR square. That means AC will be equal to PR. And now see, all the three sides of first triangle are equal to the corresponding sides of the other. That means triangle ABC is congruent to triangle PQR by which rule? SSS rule. So this is the proof of the question. We were given that two triangles are similar and their areas are equal, and we were required to prove that they are congruent, and that is the result we have achieved here. Let's have the seventh question now. Prove that the ratio of areas of two similar triangles is equal to ratio of squares of their corresponding medians. Remember the theorem? In the theorem we had, in place of medians, we had sides. But now we have to prove the same result for medians. Now for this, we need to have two triangles which are similar. So I am drawing two triangles which are similar. So this is the first triangle and this is the second triangle. You can draw them with a different size but with the same shape. Now this is the midpoint. Say ABC is the triangle and we have D as the midpoint. These two are equal. So therefore AD is the median. Here this is the midpoint. Suppose PQR is the triangle and T is the midpoint of QR. So these two parts are equal and PT is the median. So we need to write all these things which is given here. Given we have triangle ABC which is similar to triangle PQR, and in these two triangles AD and PT are the medians. So now we need to prove the result in form of the medians. So what is the result to be proved? If you remember the theorem, area of the triangle ABC and area of the triangle PQR, their ratio has to be proved equal to ratio of squares of their corresponding medians. The medians are AD and PT. So AD square upon PT square, they are the corresponding medians. Now we need to prove this result. Now for this, there is no construction to be done here. We can straight away proceed with the proof of this theorem. It may be called a theorem also because the proof resembles the proof of the theorem which we have done earlier in this video. Now we will start with the result which is given here. Triangle ABC is similar to triangle PQR. So whenever two triangles are similar, what is the result which we can use? The result which we can use is that the ratio of the areas of these two similar triangles will be equal to the ratio of squares of their corresponding sides. So since triangle ABC is given similar to triangle PQR, now this is given. Now I am using the theorem. Area of ABC upon area of PQR will be equal to the sides. I am taking AB square and PQ square because I require only one side, AB square upon PQ square. Again you need to mention the same theorem, that the ratio of areas of two similar triangles is equal to ratio of squares of their corresponding sides. So I have been using that statement many times in this video. So every time I have written it using the dotted lines, you know the result. This is the theorem which we have solved in the beginning of this video. Now this is the first equation which we will be using later. Now for the second part, we will be proving the left hand side triangles, that is these two triangles ABD and triangle PQT. Now if you see these two triangles, can we prove that these two triangles are similar? Yes, now it is a different question of similarity. Now there are not two angles which are given equal. We have to use some different criteria to prove them similar. Now for proving them similar, what we need to do is AB, the ratio of AB with PQ will be first made equal to the ratio of BC with QR. And why I am doing this? Because triangle ABC is given similar to triangle PQR. So if the two triangles are similar, then the ratio of their corresponding sides is equal. Now, if AB upon PQ equal to BC upon QR, I have to convert this BC in the form of BD. Why? Because I have to come to triangle ABD, not triangle ABC. And similarly, QR is to be converted to QT. So, what I do here is AB upon PQ will remain as it is, but this BC is actually the double of BD because D is the midpoint of BC. So I'll write this as double of BD. And similarly QR, this is double of QT. So I'll write this as double of QT and 2 gets cancelled, thereby giving a result that AB upon PQ is actually equal to BD upon QT. So just see AB upon PQ and BD upon QT. These are actually two sides of the triangles which I have shaded, and their ratio has come out to be equal. Now AB and BD I have used here and PQ and QT I have used here. Now can you tell me why this angle B is actually equal to angle Q? And you guessed it right. Why? Because the two triangles ABC and triangle PQR are actually similar, and whenever triangles are similar, their angles are equal. Also, angle B is equal to angle Q. And now using these two results, we can prove the similarity of the triangles which I have shaded. The two sides are, the ratio is same and the included angle is equal. That gives us the result that triangle ABD is actually similar to triangle PQT. Remember, not congruent, it is similar because the ratio of sides is equal, not the sides are not equal. Only the ratio is equal. So the two triangles are similar, but this time by SAS rule, not by AA rule. So this is a different question in which we are using SAS similarity, not AA similarity. Now this is the second part, and once you have proved that these two triangles, that is the shaded triangles, are similar, we can have the ratio of the corresponding sides as equal. So let's equate the corresponding sides AB and PQ. The ratio of these two sides will be equal to, now don't take BD upon QT, it is already here. Take the third side, AD and PT. AD upon PT. So just write ratio of the same thing which we have been writing all through this video, corresponding sides. And this is the second equation. Now from 1 and 2, I'll write it here for you. From 1 and 2, Now first equation was this. So I am writing it again. See, area of ABC upon area of PQR will be equal to AB square upon PQ square, but AB upon PQ has been proved equal to AD upon PT. So AD upon PT whole square, or you can say AD square upon PT square. And see, this is what was the result which was to be proved. So friends, again a very important question for board exams. So in this video, we have solved 7 important questions which have already come in board exam and solved one theorem, proved it thoroughly using all the steps. Very important video for all of you, and I hope this video greatly benefits you in the board exam. So if you like this video, do share it with all your friends, not only of your school, of all other schools also who are going to appear in class 10 board exams in March. So friends, thanks for watching this video and do not forget to click the subscribe button. The first question which I am taking up deals with the application of Pythagoras theorem, and in this question we are given a triangle ABC in which we have drawn the perpendicular from A on the side BC. That perpendicular is AD, and the relationship between BD and CD is given. This part BD is 3 times CD. So it might not look so in the figure which is drawn here, but it doesn't matter. Accuracy may or may not be there in questions of geometry, except constructions, of course. So BD is 3 times CD, and we have to prove that 2AB square equal to 2AC square plus BC square. So let's see what is given in this question. There is a triangle ABC in which we have drawn the perpendicular. AD is perpendicular to BC and BD is 3 times CD. And what is required to be proved? This is 2AB square equal to 2AC square plus BC square. Now there is no requirement of any construction to be done in this question. Why? Because we already have the perpendicular, so two right triangles are already there, so we can apply the Pythagoras theorem directly. So let's start with the proof. Now see, in triangle, I'll take the triangle on the left hand side, ADB. Let's apply the Pythagoras theorem. We have AB square equal to AD square plus BD square. And likewise in the other triangle on the right hand side, ADC. So in triangle ADC, let's write the other one below this, AC square equal to AD square plus CD square. And now we have to decide what we have to do with these two equations. So the reason for these two is the Pythagoras theorem. Either we have to add them or we have to subtract them. That depends on the sign of AB square and AC square in the thing to be proved. Now say 2AB square and 2AC square is on the other side. If you bring it to this side, this will become negative. So AB square minus AC square will be there. So we have to subtract these two. So just subtract, change the sign of the second equation, cancel AD square and write what remains. AB square minus AC square equal to BD square minus CD square. After getting to this step, we need to find out a way through which we can convert this BD and CD in the form of BC. Why? Because in the two proof we have AB square and AC square which is already there, but BC square is there. In place of that we have here BD and CD. So let's convert BD square and CD square in the form of BC square. Now how do we do that? Now see, the relationship between BD and CD is given. BD is 3 times CD. So if CD is x, then BD is 3x, because BD is 3 times CD. So the total becomes 4. Now I will write it here. BD is 3 times, see this is 3x out of 4x. So I am trying to write BD in the form of BC. So if BD is 3x, then BD can be written as 3x upon 4x. That is 3x out of 4x times BC. So 3/4 of BC. And similarly, CD is x upon total 4x. So x upon 4x is 1/4 of BC. Now you need to give the reason, since BD is 3 times CD. Now this is very important step. If you can write this step, only then you can proceed with the remaining part of the proof. So now first equation becomes, so equation 1 becomes, now I'll substitute the values of BD and CD here. AB square minus AC square equal to BD square. BD is 3/4 of BC. So if you square that up, this is 9/16 BC square minus CD square. CD is 1/4 of BC. So if you square that, 1/16 BC square, and just subtract these. They are like terms now, and they have a common denominator. So 9 minus 1 is 8. So 8/16 BC square. That is 8/16 BC square. And if you cancel this 8 and 16, this will be 1/2 BC square. And now very easy, just cross multiply this 2 here. This gives 2AB square minus 2AC square equal to BC square, which gives the desired result. This is 2AB square equal to, take this to the other side, 2AC square plus BC square. Now this is the first question proof. A little bit difficult question if you cannot write this step. BD is 3/4 of BC and CD is 1/4 of BC, because it is not directly given in the question, but rather it is indirectly derived from what is given, this statement. BD is 3 times CD. So let's see the second question now. In the second question, we have a parallelogram ABCD, and in this parallelogram ABCD, we have drawn a line BM. As you can see here, this line BM, that line BM is intersecting the diagonal AC at L, and if you produce AD, this BM produced is meeting AD produced at E. Now this is written in the question, and we have to prove that this part EL is double of BL. Now let's write what is given in this question. Now in this question, we have a parallelogram ABCD, and you can write it from here only. And line BM is drawn intersecting AC at L and AD produced at E. You can write the same thing here. So let's write the to prove part. To prove, it is EL equal to 2BL. Now again in this question, we don't require any construction, because this can be solved without the use of construction also. Now the first step in this question is to prove that triangle BMC, the small triangle here BMC, and triangle EMD, this small triangle here, I will try and prove them congruent. It is not looking congruent because the figure is not up to the scale. So in triangle BMC and triangle EMD, now for proving them congruent, we need 3 things. Now the first thing which is given here is DM equal to MC. See, it is mentioned in the question through the midpoint M. So M is the midpoint. So DM equal to MC. Given. So one side is done. The other one is the simple, very simple. That is vertically opposite angle. Angle CMB equal to angle DME. This is vertically opposite angle. And what about these two angles? Angle 1 and angle 2. They are alternate interior angles. angle 1 equal to angle 2, alternate interior angles. So see, we have proved that two angles of this are equal to two angles of this and one side is also equal. So which rule we have applied? Angle, angle, side. So that gives us the first part, that is triangle BMC is congruent to triangle EMD by AAS rule. So this is the first part of our proof, that we have to prove that BMC and EMD are congruent. Now why we have proved them congruent? We have proved them congruent because we wanted to have this side BC as equal to the side DE. So that gives us the important result that BC is equal to DE by CPCT. Now the proof will be very easy. See, BC is proved equal to DE and BC is also equal to AD. Why? Because they are opposite sides of the parallelogram. So just right here also BC is equal to AD, opposite sides of parallelogram. So what do we get from these two results? Now these two results gives us that AD and DE, they are also equal. But let's see whether we require that or not. After this, we have to use similarity also in this question. Now let's take the triangle AEL. I am shading this for you just for simplicity's sake. Now in triangle AEL, this is the first triangle, and the other one is CBL, this triangle. Now can we prove them similar? Yes, we can. Why? Because one of the angles, this angle, is vertically opposite. Angle ALE is equal to angle BLC. This is vertically opposite angles. And other one is all obviously this is alternate interior angle. See this angle and this angle. So angle EAL equal to angle LCB. This is alternate interior angles. So we have proved the similarity. That implies triangle AEL is actually similar to triangle CBL by AA root. So this is the second step. First one was the congruency and second one is the similarity. Now why do we prove triangle similar? Because we have to see that we equate the ratios of the corresponding sides. So let's equate the corresponding sides here. In AEL, if you take EL, then in CBL you have to take BL. So EL upon BL. In AEL, if you take AE, then in CBL you have to take BC. So ratio of corresponding sides I have equated, and now EL upon BL becomes equal to, now see AE. Now from here I told you that AD and DE are equal from these two equations. So if you see that AD and DE are equal, then AE can be written as double of AD. So this is double of AD, and BC is obviously equal to AD. So AD gets cancelled, and here we have the result EL equal to, just cross multiply this, double of BL. So the first question goes like this. It is an NCERT question also. In an equilateral triangle ABC, so there is an equilateral triangle. D is a point on the side BC. So let me draw the figure alongside so that you can understand it in a better way. This is the triangle, equilateral triangle, which is given. This is ABC, and there is a point D here on BC, and this BD is 1/3 of BC. It is given. So let's join this AD, and we have to prove that 9AD square equal to 7AD square. So let's see what is given in this question. Given equilateral triangle ABC and BD is 1/3 of BC. And to prove, it is already mentioned in the question, 9 AD square equal to 7 AB square. Now for this, since the to prove is in squares, we need to do a construction. We need to have right angle triangles here. There is no right angle triangle here, so we will draw the altitude. So from A, we will draw the altitude like this. So draw AP perpendicular to BC. And now we can get on with the proof. Now see, one thing we require here is AB square. So AB square will come only when we apply Pythagoras theorem in APB. So let's take triangle ABB. In triangle APB, AB square will be equal to AP square plus BP square. Now this is Pythagoras theorem. And similarly, the other thing we require is AD square. So AD square will come only when we apply Pythagoras theorem in APD triangle. So again, similarly, in triangle APD, we have AD square equal to AP square plus BP square. This is again Pythagoras theorem. And now what to do with these two equations? Now see, AD square is on this side, AB square is on that side. So if you bring it on that side, it will become minus, or this AP is not required. So this AP square has to be cancelled, and this will get cancelled only when we subtract the two equations. So let's subtract these two equations. Let's change the sign of the second. AP square gets cancelled, and thereby giving us AB square minus AD square equal to BP square minus DP square. Now after this, it's total manipulation, total just simplification of this expression to get to the final expression. See, AD square and AB square we already need, so I will not touch these two. I will modify these terms. Now see BP. BP is actually, it is half of BC. Why? Because the altitude bisects the base. In case of an equilateral triangle, the altitude bisects the base. So in place of BP, I can put half of BC. And what about DP? Now DP is, directly DP is not given, so I will represent DP in the form of BP and BD. So it is BP minus BD, and BP I already told you it is half of BC, minus BD, it is given in the question 1/3 of BC. Now they are like terms, and when you subtract them, 3 minus 2 is 1 and 3 2 is 6 BC. So I have taken the LCM and simplified this and brought it in the form of BC. So this expression 1 will now become AB square minus AD square equal to, now BP square, BP is half BC, so 1/4 BC square, and DP square is the square of this 1/36 BC square, and these two are like terms. Now you can take the LCM and simplify this also. This will become 36 is the LCM, so 9 BC square minus BC square. That implies AB square minus AD square will be 9 minus 1 is 8, so 8 upon 36. Now 8 upon 36 can be further reduced. You can cut out the common factor, 4 upon 18, 2 upon 9. So it will become 2 upon 9 BC square. And what next? We don't require BC also. We required only these two. Now see, since this is an equilateral triangle, the side BC is actually equal to the side AB. That's what I require in the question, AB. So now put BC equal to AB. That will give you AB square minus AD square as 2/9 AB square. And rest is very easy. You can just bring AB square down this side. AB square minus 2/9 AB square will be equal to AD square. And if you simplify this, 9 minus 2 is 7. So 7 by 9 AB square equal to AD square. And just cross multiply, you will get the desired answer 9 AD square equal to 7 AB square. A very important question and a very easy also. If you have solved it once, then you don't need to do it two, 3 times. So students, practice this question. This is the exact sequence of steps you need to follow. Let's see the second question. In this question, we have two poles of height A and B which are p meters apart. So I'll draw the figure for this also. See, this is the first pole, this is the distance between them, and this is the second pole. Now, if I join the top of this with the bottom of this and top of this with the bottom of the first pole, then this point, this is a point of intersection, and I'll draw the height of this point. Now, the first pole, say I'll call this as A, call this as B. It is given the heights are A and B. You can take anywhere. And this height I'll assume as H. So in the question, I need to prove that this H is actually AB upon A plus B meters. Now this is the question given to us. Now let's name this figure first. A, B, C, D, P, Q. So these are all right angle triangles. Now the distance between them, that is this distance, is given as P. I'll assume BQ as X and QC as Y. So let AB equal to B, DC equal to A. These are the poles. Let PQ equal to H, BQ equal to X, and QC equal to Y. These three things are to be assumed. Also, these two distances X and Y, they add together to give you P. Now this is given in the question. And now we need to prove that H is equal to AB upon A plus B. Now for this, we need to make use of similarity of triangles. Now first thing is to take the triangles from the left hand side. ABC and PQC. Now triangle ABC is similar to triangle PQC. You can see AA rule is applying here. One angle is 90 degree and this angle is common. So ABC and PQC, these two triangles are similar. I have not written the two angles, you can write it down. And that gives you the ratio of corresponding sides will be equal. So I am equating the corresponding side, ratios of the corresponding side now. What is the base of this big triangle? It is P. Base of small triangle, it is Y. Height of big triangle is B. And this height is H. So from here, take the value of Y. So Y will come out to be PH upon B. Now this is the first step you have to follow. Now similarly, you have to take the triangles from the other side also. From this side, DCB, triangle DCB is similar to triangle PQB. This is also AA rule. And when these are similar, then again you can derive one more result. From this side, the big triangle, the base is P. And here the base is X. Here the height is A. And here the height is H. And from here, you get the value of X as PH upon A. Now this is the second part which we required. Now after having got to these two parts, our work is very simplified. Now let's consider the base X plus Y. X plus Y is actually equal to P. What is the value of X? It is PH upon A. So I am putting here PH upon A plus the value of Y, PH upon B is equal to P. Now from here, P gets cancelled throughout. So H upon A plus H upon B equal to 1, and when you take H common, this will be 1 upon A plus 1 upon B equal to 1, thereby giving you the LCM as AB and numerator as A plus B. So if you take this term that side, the value of H will come out to be AB upon A plus B, and this is what was required to be proved in this important question. So students, practice these two questions, very important for board exams, and I am sure with little luck you may get one or two questions of these kind in exams. Friends, if you are liking these videos of triangles chapter, then please do not hesitate in sharing with any of the students who are appearing in boards this year. I am sure this is going to help them a great deal. And if you have not clicked the subscribe button, then just do it, and thanks for watching.